Hello class. In our last class, we have seen the numerical based on empirical and molecular formula, and we have learned how we can calculate the empirical and molecular formula if the percentage composition of the element and either molecular mass or vapor density is given. Okay, so that was our last topic. Now today we are going to see the numerical based on chemical equations we called, or we also call stoichiometry. Okay, stoichiometry deals with the calculation of masses or volumes of the reactant and the product involved in a chemical reaction. So in this we'll learn how to calculate the mass of the reactant as well as the product, okay, and as well as volume as well in a chemical reactions. Stoichiometry is derived from two Greek words, stoichiotion, which means element, and metron means measure. Now let us consider one example to understand this thing. Say for example, consider the combustion of methane, and the balance equation for this reaction is given as this one. So methane reacts with oxygen to form carbon dioxide and water molecule. So the first thing is that we need to balance the equation. Say for example, if methane, oxygen, carbon dioxide and water is only given, first we will balance the equation. Now after that, according to the above chemical reaction, what is understood that 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. So it is understood from there, 1 mole of methane reacts with 2 moles of oxygen to give you 1 mole of carbon dioxide and 2 moles of water. Similarly, 1 molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide and 2 molecules of water. So in terms of molecule, if you have to see, 1 molecule of methane reacts with 2 molecules of oxygen to produce you 1 molecule of carbon dioxide and 2 molecules of water. Similarly, if it is a gas, so 22.4 liters of methane reacts with 44.8 liters of oxygen. So in terms of volume, if you have to consider, since it is 1 mole, so 1 mole of any gas at STP occupies 22.4 liters as we know, and since here we have got 2 moles, it becomes double, 44.8 liters, and it is also 1 mole, so 20.4 liters, and this is liquid, so over here and 2 mole, so 44.8 liters. Okay, and similarly, if you calculate the molecular mass of this methane, molecular mass will come as 16 grams. So 16 gram of methane reacts with 2 into 32, because oxygen will have 32, to give 44 gram of carbon dioxide, and this will be 2 into 18 grams. Okay, so this thing you need to know when you have got the chemical equation, how many moles is reacting with how many moles of other substances, then what is the volume occupied, then what is the gram, and that this what is the weight. This can be found from the molecular mass. Right. Now in solving this problem, we'll proceed as follows. What are the different steps that we need to do? First, write a balance equation for the reaction. That will be our first job to do in this numerical. Then we will write down the molecular weight of each substances below its formula. So we will write down the molecular weight of the substances below it by calculating it, and the same units of weight and volume should be used throughout, and the unit of weight and volume that you are using should be same. And after that, write down the product of 22.4 liter and the number of molecules below each gaseous substances. So what you can write, if we have got a gaseous substances, you can write its volume 22.4 liters for 1 mole, for 2 mole 2 into 22.4, like that. Okay, so now let us proceed with the numerical. A question is there, a solution of common salt when added to silver nitrate solution yields a precipitate of silver chloride, which is 0.28 gram. Find the mass of sodium chloride in the solution, and also find the mass of sodium nitrate formed. Okay, so the condition is given to you and the equation is not given, and it has mentioned that common salt, that means sodium chloride, reacts with silver nitrate solution. So common salt reacts with silver nitrate solution, and it gives a precipitate of what? Silver chloride, AgCl, and so the other byproduct form will be sodium nitrate. Okay, this is the equation. Now the first thing that you need to do is you find out the molecular mass of the substances. Sodium chloride 23, here the atomic mass of chlorine is taken as 35.5, so when you add it, it becomes 58.5, and for silver chloride it's 108. The atomic mass of silver is 108, chlorine is 35.5, so which will come as 143.5, and similarly the molecular mass for this will come as 85. Now in your question you just see what is asked to you. Find the mass of sodium chloride in the solution. That means you need to find the sodium chloride, and what is the product of precipitate form? 0.28 gram. So this silver chloride form is 0.28 gram. So from that is only given, okay, the mass of silver chloride formed. So from that you are required to find out the mass of sodium chloride and the mass of sodium nitrate form. So you need to find the sodium chloride mass and sodium nitrate form. So first thing what you can write from this equation after calculation of molecular mass, 143.5, that means this gram of silver chloride is formed from what? 58.5 gram of sodium chloride. Fine, this is from the equation. So what you can write, since we have to form from 0.8 gram, so 0.28 gram of silver chloride formed from 58.5 divided by 143.5 into 0.28, okay, which will come as 0.114 gram of sodium chloride. So we found out the first value, okay. Similarly for the second, also find the mass of sodium nitrate form. Now we came to know that the sodium chloride that is used is 0.114 gram, okay. Now from this what you can say, 58.5 gram of this is, okay, 58.5 gram of sodium chloride forms what? 85 gram of sodium nitrate. This is from the equation only. Now we have calculated the mass of sodium chloride, so we had find for this weight 0.114 gram of sodium chloride forms 85 by 58.5 into 0.114, so which will come as 0.165 gram of sodium nitrate. So this is the answer. So one answer is 0.114 gram of sodium chloride, another answer is 0.165 gram of sodium nitrate. So this is how you can do the numerical based on the mass calculation. Now we'll see the second numerical, which is based on the mass and volume calculation. If you have got mass and volume calculation, how to do? Say for example, if 16.4 gram of calcium nitrate is heated, calculate the volume of A, nitrogen dioxide obtained at STP, and B, the mass of calcium oxide obtained. Over here also the equation is not given, but what is given? Calcium nitrate is heated, and as calcium nitrate is heated, it will form calcium oxide, nitrogen dioxide and oxygen, okay. These are the products. Now once again what we'll do is we'll balance the equation first. So in balancing equation, this will be 2 molecules, this will be 2 molecules, this will be 4 molecules, and this will be only 1 molecule. So after this again we'll calculate what? Molecular mass of each substances, okay, molecular mass of each substances. So molecular mass after calculation it will come as 328 gram, calcium oxide it will come as 112 gram, and nitrogen dioxide it will come as 4 moles, and since it is a gas we'll keep it as a moles, okay. Now from the equation, first it is asked to find out the volume of nitrogen dioxide obtained at STP. That means what is the volume of this nitrogen dioxide formed, okay. So for that, if you see there is a 4 moles, and we know that 1 mole is 22.4 liters. So what I can write, 328 gram of calcium nitrate liberates 4 into 22.4 liter. Why it is 4? Because it is 4 mole. For 1 mole it is 22.4 liter. If it is only 1 mole, we write only 22.4 liter, and since it is 4 moles, we write 4 into 20.4 liters, okay. So this much. But in the question it has been asked what is the weight of calcium nitrate given? 16.4. So we'll take that weight, 16.4 gram will liberate 4 into 20.4 liters divided by 328 into 16.4, which will come as 4.48 liter nitrogen dioxide at STP. So the volume of nitrogen dioxide formed at STP is 4.48 liters. Then we have got the second calculation, the mass of calcium oxide obtained. So what is the mass of calcium oxide obtained if we use this amount of calcium nitrate? So from once again from this equation only what you can write, 328 gram of calcium nitrate, okay, gives how much? 112 gram of calcium oxide. So therefore 16.4 gram will give what? 112 into 16.4 by 328, which will come as 5.6 gram of calcium oxide. So this is how we calculate the numerical based on mass and volume calculation, okay. So I have shown you 2 examples explaining this numerical. So based on this understanding, this will be your today's assignment 8. Question number 1, How much calcium oxide is obtained by heating 82 gram of calcium nitrate? Also find the volume of nitrogen dioxide evolved. Okay, so the equation I have already provided to you. So how we have understood the previous numerical, based on that you please do it, this thing. Question number 2 is, what volume of carbon dioxide gas at NTP can be obtained from 500 gram of calcium nitrate? Once again, using the same concept, please complete this 2 question and please submit in the link that is provided to you.